All right, hey y'all. We're going to continue our lesson over quadratic expressions and we're going to be focusing on adding and subtracting. The most important thing to remember is that our final answer must be written in standard form. Ax squared plus bx plus c. That means my quadratic term comes first, my linear term comes second, and my constant term comes last. We're going to look at three expressions and we're going to use the same steps every time to kind of keep us focused. For every problem, we will first identify our like terms. We will rearrange them so that they're side by side, and then we will combine them. Same step, every problem. So let's get started on first problem. Problem number 1 says 3x squared plus 4x minus 8, and we're going to add that quadratic expression. We're going to add that quadratic expression to negative 7x squared plus 2x plus 3. So like I said, first we're going to identify our like terms. Like terms have the same variable and the same exponent. So for our first example, our quadratic term, which we want to come first, would be 3x squared and negative 7x squared. My linear term, which we want to come second, will be positive 4x and a positive 2x. And then my constant term, which does not have a variable, would be a negative 8 and a positive 3. So we have identified all of our like terms because they had the same variable and the same exponent. So now I have green with green, blue with blue, and purple with purple, and that is how we will rearrange them. So now I'm going to rewrite my expressions so that they'll be together according to their color. So first I'm going to group 3x squared minus 7x squared together. And we're going to add it to my blue, which is positive 4x plus 2x. And then we're going to add it to my purple, which is negative 8 plus 3. Now, this doesn't change the value of the expression up here that we started with. We just rearranged it so it'll make the math be a little bit easier. So now we're going to combine our like terms. When we're combining like terms, we are simply focusing on the coefficients, aka the numbers that are in front of the variables. Especially if I want to use my calculator, because if I want to use my calculator, I can't put the letters into it. So for my quadratic terms, 3x squared minus 7x squared, my coefficients is positive 3 and negative 7. That is the only part I can put in the calculator. So I can put 3 minus 7 into my calculator, which tells me that 3x squared minus 7x squared is equivalent to negative 4x squared. And then I do the same thing for my linear terms. My coefficients for my linear terms is a plus 4 and a plus 2. I know it is a plus 4 because there is nothing in front of it, which means it's not negative. So when I get ready to put that in my calculator, it's the same. 4 plus 2. Hopefully we won't have to do that, but if you do, go ahead. So that would give me plus 6x. And then for my purple ones, aka my constants, negative 8 plus 5. Which will give me minus 3. So our final answer, written in standard form, is negative 4x squared. It's negative 4x squared plus 6x minus 3, which gives me a quadratic term of negative 4x squared, a linear term of a positive 6x, and a constant term of negative 3. So, Ms. Carter, how can I check my answer without cheating and using ChatGPT and all Papa Math and all of the other things that y'all be using? I'm going to use my Desmos graphing calculator because all we're talking about is equivalent expressions. So I would know that my answer is correct if I use my Desmos calculator and when I type my answer in, it's the same parabola. So I've already typed in my initial expression, which was the one that we added together, and this is the parabola that they gave me. If this answer is correct, when I type it in, it will match that parabola. So let's see. Negative 4x squared. Notice they're not matching yet. Plus 6x. They are still not matching yet. Minus 3. Oh, and that's not right. Because if they was right, it'll be matching. So we got to come back over here and see what we did wrong. And what we did wrong was negative 8 plus 3 don't give me no negative 3. It give me a minus 5. So now I come back to my calculator. Because I got to change this too, huh? And I put minus 5. And does it give me a matching parabola? Now my answer is correct. So my final answer should be negative 4x squared plus 6x minus 5. Let's look at another one. All right, so our second example has 6 minus m squared plus 4m plus negative 2m plus m squared plus 1. So you might say, Miss Carter, this isn't a quadratic because it's not written in standard form. Well, it is a quadratic because my highest exponent is a square. So just like old-fashioned, like we did last time, we're going to identify our like terms. So my first term that they gave me is not a quadratic, though. It's a constant because it doesn't have any variables. So I'm going to color that one purple. Then I have minus m squared, which gives me my quadratic term. And then I have plus 4m, which gives me my linear term. And we're adding it to negative 2m, which is my linear term, plus m squared, which is my quadratic term, plus 1, which is my constant term. So now we're going to rearrange them so that all of my like terms can be together. But when I rearrange them, I want to rearrange them so they look like standard form. So if I want it to look like standard form, which color is going to come first? The purple, the green, or the blue? Hopefully you said the green. So I'm going to group negative m squared. Let me erase this so that'll be a little bit. So I'm going to group negative m squared plus m squared, and I'm going to add it to my linear terms. So that I'm going to group the blue ones together. 4m minus 2m, add it to my constant terms, my purple ones. 6 plus 1. So again, I can use my calculator if I need to. I have negative m squared plus m squared. And I know you're probably saying, well, Miss Carter, you said we can't put the letters in there, but I can put the coefficients. Well, what is the coefficient if I don't see a number in front of the variable? Yes, 1. So this is actually negative 1m plus a positive 1m. So negative 1 plus a positive 1 gives me 0, which means they cancel out. If my mama gave me 1 square and I take the square away, I don't have no more squares. So these cancel out because they equal 0, which means I won't have a quadratic term. And so I come to my linear terms. And my coefficients are 4 minus 2. And so 4 minus 2 is 2. So I get 2m, and then plus 6 plus 1 would be plus 7. So I started off with a quadratic expression, but once I combine my like terms, those canceled out, and it didn't give me a quadratic answer. So what's my quadratic term? I don't have a quadratic term because my quadratic terms canceled out. Well, what's my linear term? 2m. And what's my constant term? 7. All right, let's look at our last example. So our last example says negative 2y plus 4 And I'm going to add it to negative y squared plus 5y minus 6. So again, we're going to identify our like terms. So in my first one, I only have two terms. Those two terms are known as a binomial because it's only two. I don't have an ax squared. I don't have that. All I have is a bx because it does not have an exponent. So that bx term in this case is actually negative 2y. All because it has an exponent of 1 plus my constant term of 4. And I want to add it to this quadratic term of negative y squared plus a linear term of 5y minus a constant term of negative 6. So I have identified all of my like terms. Now it's time to rearrange them so that the green is with the green, the blue is with the blue, the purple is with the purple. So I only got one green. So first I'm going to write negative y squared. I can't group them with nobody because that's all I got. And then we're going to add it to my linear terms. So my blue ones, all the ones that have an exponent of 1. So that would be negative 2y plus 5y. And then we're going to add it to all of my constant terms. 4 minus 6. So my green one, I don't have to put it in the calculator because it's only one green one. I'm just going to bring it down. So I get negative y squared. And I'm going to add it to negative 2 plus 5, which is going to give me a positive 3y. And then 4 minus 6 is going to give me a negative 2. So my quadratic term would be negative y squared. My linear term would be 3y. And my constant term would be negative 2. So let's check our answer with our Desmos calculator and see if we are correct. So my first group will be negative 2y, but I can use x. It doesn't matter. I don't have to use y. Plus 4. And I'm going to add it to negative x squared plus 5x minus 6. And this is the parabola that I got. So we're going to put our final answer in there. Negative x squared plus 3x minus 2. They match. So we were right. All right, guys, I hope you learned a lot about adding polynomial expressions. And polynomial also means quadratic. All right, guys, I hope you learned a lot about adding and subtract All right, guys, I hope you learned a lot about adding quadratic expressions by first identifying your like terms, by second rearranging them so that they are together, and then 3 combining your like terms by identifying your coefficients and using your calculator if needed. All right, y'all. Now we're moving into subtracting quadratic expressions. This is a continuation of what we just did with adding. Most of the steps are going to feel familiar, and just like before, our final answer must be written in standard form. Ax squared plus bx plus c. So what's new? Well, I have this quadratic expression, and this is a subtraction problem because in the middle of the two expressions, there is a subtraction sign. But I want to rewrite this subtraction sign as addition so it can look like the problems that we just did. I can't just make this a plus sign, though. I can't just change this minus sign and put it as a plus sign. Instead, I have to distribute the negative sign to each term in the expression behind it. Once I do that, everything works just as before. So let's look at the very first one. Since this expression, 4x squared plus 7x plus 1, I'm not doing anything to it. I'm just going to rewrite it. I'm going to bring it down and just rewrite it as it is, which would be 4x squared plus 7x plus 1. But remember, I said I want to rewrite this subtraction problem as an addition problem. And to do that, I'm going to distribute this negative sign to each one of these, meaning I'm going to multiply a negative to a positive 8x, which will make it, change it now into a negative 8x squared. And when I distribute the negative to positive x, that will change it to a negative x, or you can say negative 1x. Then I'm going to take the negative sign and distribute to the negative 7, which will make it a positive 7. So we have successfully rewritten this subtraction expression as addition. Sorry. Now I want to identify what my like terms are, because I can do that now since I have rewritten it. So my quadratic terms are positive 4x squared and negative 8x squared. My linear terms are plus 7x minus 1x, and my constant terms are plus 1 and plus 7. So I want to rearrange them so that they are side by side so I can see them clearly, which will be 4x squared minus 8x squared plus my two linear terms, which will be 7x minus 1x, plus my two constant terms, which will be 1 plus 7. So just like before, when I'm getting to combine my like terms, I can't, if I want to use my calculator, I can't put the variables in there. I can only put the coefficients. So my coefficients for my quadratic terms would be 4 minus 8. So that's the only part that I can put in the calculator, which will give me negative 4. So 4x squared minus 8x squared is negative 4x squared. Plus my coefficients for my linear terms, which will be plus 7 minus 1, which will give me a positive 6x, plus my constant terms, which will be plus 1 and plus 7, which will give me plus 8. So before we identify our quadratic, linear, and constant term, we're going to use our Desmos graphing calculator just to make sure that we did it correctly. So just like before, I typed in my original expression, and I want to see if the expression, the final answer that we got, is equivalent. So I'm going to type it in, negative 4x squared plus 6x plus 8. And since they are on top of each other, which means they are literally the same, my answer is right. So that would make my quadratic term be negative 4x squared, my linear term be 6x, and my constant term be a positive 8. All right, let's look at problem number 2. So again, this is a subtraction problem. That's why it's a minus sign in the middle, and I want to rewrite it as addition. So I'm going to distribute the negative sign to all the terms behind it. So since for my first expression, I'm not doing anything to it, I'm just going to bring it down. I'm just going to write it as is. 6p minus p squared plus 9. And since we're rewriting this as addition, that minus sign is going to change to a plus. And we're going to go ahead and distribute. Negative times a positive 12 would be negative 12. A negative times a negative 2p squared would be positive 2p squared. And a negative times a negative 2p would be a positive 2p. So now I'm going to identify my like terms, aka my quadratics with my quadratics, linears with linears, and constants with constants. So since 6p does not have an exponent of 2, it has an exponent of 1 that makes it my linear term. Negative 2p squared would be my quadratic term, and plus 9 would be my constant term. Then my negative 12 would be my constant term. 2p squared would be my quadratic term, and 2p would be my linear term. So now we're going to rearrange them so that they are side by side. And since I want to rearrange them and I want my final answer to be in standard form, my quadratic term should come first. So negative p squared plus 2p squared added to my linear terms, 6p plus 2p added to my constant terms, 9 minus 12. All right, so again, when I'm combining my like terms, I'm simply combining my coefficients. So the coefficient in front of negative p squared would be a negative 1. And the coefficient in front of this one would be plus 2. So negative 1 plus 2 would give me 1. So negative p squared plus 2p squared is equal to p squared. My coefficients for my linear terms would be 6 plus 2, which would give me 8p. And for my constant terms, it's just 9 minus 12, which would give me negative 3. So we have rewritten our expression. And that would make my quadratic term be p squared, my linear term be 8p, and my constant term be negative 3. All right, let's do our last one. All right, again, we have a subtraction problem, and I want to rewrite it as addition. So what should we do first? That's right, we should distribute the negative sign to each term in the expression behind it. So since I'm not doing anything to the first part of the expression, what should we do? Right, we're just going to bring it down. So 7v squared minus 2v, and we're changing this subtraction problem to an addition problem. And so let's go ahead and distribute. Negative times a positive 2v would give me a 5v would give me a negative 5v. A negative distributed or multiplied to a positive 8 will give me a negative 8. And a negative times a negative 3v squared would give me a positive 3v squared. So basically, when we're distributing the negative sign, we're just changing the signs of everything behind it. Notice the 5v changed to a negative 5v, positive 8 changed to a negative 8, negative 3v squared changed to a positive 3v squared. We're just taking the opposite of the second expression. All right, so let's identify our like terms. My two quadratic terms would be 7v squared and positive 3v squared. My linear terms would be negative 2v and negative 5v. And I only have one constant term this time, which is negative 8. So we're going to rearrange them so that they're side by side. So I have 7v squared plus 3v squared, and we're adding it to negative 2v minus 5v, and we're adding that to a negative 8. So my coefficients for my quadratic terms are 7 plus 3, which would give me 10. So 7v squared plus 3v squared gives me 10v squared. My two coefficients for my linear terms, negative 2 and negative 5, will give me negative 7. So negative 2v minus 5v is negative 7v. And then I just have my plus negative 8. Which would just give me negative 8. So let's review the big idea here. Subtracting means to distribute the negative. After that, it just becomes an addition problem where all we have to do is identify our like terms, same variable, same exponent, rearrange them so that they are side by side, and then combine our like terms. And always remembering to write your final answer in standard form.